You know what, I was hoping I wasn't going to see one of these again. It's a DNT base station. And the last two, we've lost money hand over fist doing. So, before we rebuild the power supply, we're going to make sure we can get this thing to work. So it looks like an M40 base, a mobile, but it's got the DNT mic, which is just like the standard replacement mic we use. Yeah, that's the right one with the plastic plug. Anyway, we'll probably use our standard replacement, which is new and not 40 years old. So the DNT big problem is that they were suffering from dry joints when they were brand new. The warranty returns were massive. So trying to get them to last the year of the warranty was quite difficult. So apart from them being bleed over boxes, and there was a super tuned version, which was UK remanufactured by Cleartone. I'm not bothered about bleed over boxes. I'm in the middle of nowhere, and there we go. And anyway, it's not like there's people in terrace houses every other house with CB these days. Mind you, you've got the burner brigade and all that rubbish. So we've got a crystal filter there, and I never know whether it's supposed to be there or not. They go lopsided, but that doesn't bother me. Disconnect the speaker. I'm not going to rebuild this until we know it works. It's a lot of work doing that, and you know, we end up charging like £4 an hour to do that, and I suppose I could charge more, couldn't I? But it just makes them not worth it. So we'll power it from this is a 12 volt power supply. It's not 13.8. So we need to make sure we run the set at no more than 12.8 volts. So that's what we'll do. I'll better connect an extension speaker. I think he says there's no transmit. You can have a nightmare dry joint between the socket at the back and where it would be on the mobile. They work okay when they work, but the dry joints are such that there you are. So we'll connect power, we'll put one to chassis, we'll put one to the on and off switch, just like that. We'll switch on, and the meter lamp doesn't work. So channel 20, we're on high power. Have we got a hiss? We've got a hiss. So let's put 2779125 on the signal generator and see whether it receives. Picture in picture on. 2779125. 2779125. And whatever it did at his house, it probably doesn't do here anyway, because it's been in the post. 2779125. Interesting. There we go. This is deaf as a post. Am I doing something wrong here? That's 3 microvolts. Right. So we're going to transmit. At the moment my ammeter is showing 0.146, which is what you'd expect. So we're going to transmit. It's now it is transmitting. It's doing 380 milliamps. It's transmitting more or less on frequency, and it's producing 1 watt. So low power, it's producing 1 watt. High power, it's producing 1 watt. Low power, it's producing 1 watt. Low power. How bonkers is that? How can it be the same? Perhaps somebody's shorted the switch out, so it's always on high power. Now, if it was drawing 900 milliamps and only delivering 1 watt, then I would suspect there to be a problem connecting between the radio's normal chassis and there. But it isn't doing that. But it's as deaf as a post. So, how deaf as a post is it? We'll plug the test equipment in. We need an earth on these sets. Put one on anyway. Just look at the SINAD meter. It's 7.4 microvolts for 12 decibel SINAD. I did do a sheet for this. I'll leave it on the printer. Did I put it somewhere stupid? Probably. One watt, 27,79114, 7.4 microvolts, 6.5 microvolts. Will it ever do 20? No. Meter lamp doesn't work. Doesn't have PA. Right, I wonder. It might be tuning. You know, it could be tuning. We'll just see. I'm not going to do the synthesizer setup at this point, but I just want to see if it's off frequency. To plug my second signal generator, I have to switch off the computer printer. They don't like them just being unplugged either, do they, these printers? There we go. Right, so take the tone off, put a bit more signal on, take the tone off, switch our backup signal generator on. We'll just see how far off frequency it is. Can't remember which is transmitting, which is receive. Doesn't matter, I can soon correct it. It's not that one. So just put it on frequency the quick way, because I will need to do the 10.24. and just putting it on frequency back on transmit. (79125). Right, receive, tone back on. Just see whether it's front end. What I don't want to do is spend time on this if it needs major receiver work, because it's jolly well will just go back. Let's go back to the SINAD meter. That was spot on. That wasn't. Just see where we are now. (12 dB) is now 7. Where was it before? 7.4. Gained a bit. Not a lot. Not sure why that doesn't fit, because it's supposed to. See whether that one fits as different type. That's brought it up a bit as well. It could just have had screwdriver trouble. See where we are now. That's brought it to 5.5 microvolts. Still rubbish, isn't it? Once we get down to like 2.5, we're at Cobra standard. That's not saying much, is it? So let's put a big signal on and see if we can. I'll put the oscilloscope on. I'll show you that later. Shall we look at the detector now? I'll put 100 microvolts on. We'll look at the detector now for giggles. Well, that was out, wasn't it? But that can sometimes not help. Let's look at this one. And then manipulate that one. We've certainly got the sine wave now. You can just hear it at 1 microvolt. Might get a mile range out of this now. Back to there. Go through these again. Now the IF straightened out. So that was spot on as I'd left it. That was spot on as I left it. And so was that. Now, something on there's an IF injection one. Is it that one? Or am I going to knock the whole thing out of kilter if I do that?
Have I still got the service manual, or have I burnt it? Because that's what's going to happen. Yeah, we've still got some.
Might be able to do something with that one. Nope. So the circuit for the B40 is here. And it does show ceramic filter. So it's not deaf enough for there to be a DUF transistor, but it's deaf enough for there to be a DUF filter. You can't just put a crystal filter in place of a ceramic one. And what I'm tempted to do is to take that out as a possibly temporary measure and see whether it fixes the radio. You can always have it back in a jiffy bag, can't you? And who's to say that's the right one and the right insertion method? Is there a screwdriver that actually fits on here? I mean, these are all long-necked. Probably end up drilling this one out. I did buy some replacements actually, because they're not the normal size. Yeah, that's got it started. It's supposed to be on 2.5. There's times we've re-drilled them for and tapped them for M3. I just don't know what's right and what's wrong on these. It's such a mess. Right, I'll just find a second-hand ceramic one. Okay, so I've taken the filter out. I tried a ceramic one, but the ceramic one made it worse, so it must be made to be on a crystal filter. I tried another crystal filter. It's exactly the same. So put the original one back. What I did find is the local DX switch needs cleaning. So getting that in the right position has brought the RF gain up. It was if it was in the RF attenuated position. It's a bit of that's something which we'll do something about. So now the sensitivity is just less than 0.5 microvolts, just what as you'd want. So transmit very quickly. I've got other things to do. I'm just going to put it into low power and key up. Let's go to the right meter and see what happens when we turn the preset. So we're having some effect, and we can set 400 milliwatts. So let's go back to full power. It's a switch, isn't it? Because this radio absolutely stinks of fags. It's got nicotine in the switches. I might have to get Mr. Chippie to dismantle the switches. Yeah, that's what's wrong with it. There we are. Look at that. There she blows. 3.8 watts. So, quick tune of that. Quick heat it up. Centre of the peak. I did dry joints as well while I was at it. 3.8 watts. Right, it's worth rebuilding the power supply on then, now we know it's basically working. Right, I'll be back. I'll probably have done the power supply when I do come back. And that might not even be today. Just before we take it off the bench, I'm just going to do the deviation. It's reading 2 kilohertz on the test set behind with this mic. See what we can do. Wow, no, we can't get any more gain out of it. So I would presume the mic stuff, so we will have to come back to it with a different mic. Right, well, there we are. We're actually done. Customers got a new plug on there, but it had a 13 amp fuse in it, so we've changed that for a 3 amp fuse. We've got new capacitors in the power supply, 1000 microfarads at 35 volts, 2200 microfarads at 25 volts. You can see it's starting to recede the thing because it's been overheated, this tubing, and that read really high. So they're replaced both with 35 volts, and certainly that one's of the highest quality. So I didn't dare plug it in before. Where we've done some dry joint thing here and round the receiver, and where I looked at the filter, that's been done with isopropyl alcohol. So as when I switched off the video, I'd actually done a quick tune on the transmitter, and I discovered that the high-low power and the high-low RF gain, both the switches were problematic. Mr. Chippie's dismantled the switches. Don't just spray switch cleaner in, fronts off, switches out, dismantled, cleaned manually, reassembled. So a lot of work, but it gives a good result. So here's the thing. And the other thing I checked was deviation. And deviation was at full on the radio, but was inadequate. So we're going to, where we left off was with the customer's mic. So this time I'm going to plug it into the mains. And find we've got absolutely nothing. Of course, what I failed to realise is the meter still needs doing. So we're going to run out of time. If I can't fix this in 20 minutes, we can't do an on-the-air test today. So let's see where we are with this power supply. Maybe it doesn't work even after rebuilding it. Got nothing there. Got nothing there. Unplug it. So got a duff fuse. Ah, oh, look at that. Bits of wire wrapped around the fuse holder. Well, it's probably 1.25 because I don't know what it's supposed to be, but it kind of figures. So I can't tell until we power it up whether it's going to go pop. So I will go and find a fuse. Right, that's changed the fuse and it's now lit up. Now we need to check the volts, and it should be somewhere around, got glare on that, haven't I there? Should have somewhere around about 12.2 or something. Not variable, it's a very basic power supply. We're using a regulator IC. Prone to humming if the capacitors aren't changed, if they're not blowing fuses, that is. 11.9 is on the output, 19.6 on the input, so that's about what you'd expect. Probably do 3.6 watts. But before we do that, we're going back to the deviation. Just listen to it on the walkie-talkie first. Testing 1 2, testing 1 2. So we know it's transmitting. Wow, it's 2.1, 2.2. It is acceptable, just not ideal. So we'll now try it with our normal standard replacement mic. Where have I put this sheet? Unbelievable. It's got bungled with that, hasn't it, with the service information. So at the moment we've got 2.1 and deviations at full. So we'll just see what the deviation is on a standard replacement mic. I've just put a plastic 5-pin DIN on this. Normally we use metal ones, but there you go. Wow, that's 2.5, 2.6, so it can just pop down a fraction, which is what I thought was going to happen. Wow, there we go. Now we can listen to it on here. Testing 1 2, testing 1 2 3 4 5. So that seems okay. So back to this test set. Out of interest, when we put back into the Marconi test set, what the test set thinks of the deviation itself. Sometimes it lies, sometimes it doesn't. Wow, it looks about right today. So that's that done. I'll have to come back to doing the meter lamp. There's no time today. It's banging across, which is ridiculous, and it is one of these two presets. So quick look in the notes, and it's going to be the last page I find, and if I went the other way it'd be the first, but it would still be the last page, we all know that. Yeah. So the meter, I find we should be checking the power first. What's been the centre of the red zone, if you can see that centre of the red zone on high power, and the transmit power, are we still in picture in picture? Yes. It's just doing 3 watts. So we'll just go through the tuning. Now it's on this power. It's a bit like a new set, isn't it? They never do 4 watts. There is one in there. There is. You know, these are great to have as a working thing in your collection, but they're not a great set to be the only set you own. It's doing 3 watts. So let's see what's doing on the other channels. Channel 40, it's doing 3 watts. Channel 1, it's doing 2.8 watts. watts, 2.8 watts, 3 watts. On low power, our low power preset is there, and that is doing 400 milliwatts. It was actually full, so it's now 400 milliwatts, and we don't know what the current now is, but it's well within what you'd expect. We could disconnect it and reconnect it to the power supply, but it's not proving anything because we know the thing works. So that's transmit. We've done the deviation, we've done the power. We need to do the receive, which we'd already tuned. Back to channel 20. Just connect the test gear up just to get the figures. It's already been tuned. And it was as deaf as a post, if you remember when it came in. Excellent. So go over to the SINAD meter. We did frequency. And that's still spot on. That was full scale deflection, so FSD is now correct. The S meter is supposed to be S9 for 100 microvolts, and it's a bit generous, so it's what? 2527. Soon remedy that. So 27. now need to tune that for 100. And there we have S9 at 100. I'm just going to do a final check on the detector because of all the shenanigans with filter tests and that. I'll just go back on the oscilloscope. Now we'll get a SINAD reading. "12 microvolts is now 0.51 12 dB is now 0.51. .51 microns, better than 7.4, isn't it? 0.41, and hopefully it'll achieve 20 dB as well, but not all sets do. It does, and it's doing that at 1.8. Now we never touched the squelch because I couldn't go through that with it being the way it is. I don't think, is it adjustable on these? No, it's not, is it? Got deviation, low power, transmit meter, receive meter. So what you get's what you get. So let's have a look. We'll go over to the attenuator, turn the squelch down, see what the sensitivity is. So set the squelch on the radio. Put the signal generator on. Sparked at 0.3. It's coming in at 0.3. And do the opposite. Keep the signal generator on, and now put the squelch to full. It's probably what it's going to be, about 30. Let's see. That's 1, 3. It's very wishy-washy, isn't it? No wonder it's got an RF gain control switch. It's just 2.5 microvolts at full squelch. Now, if we put RF gain on, it brings it to 18 microvolts. There we go. Are all done. Apart from the meter lamp, which I'll have to do another day. We'll just see whether the speaker works. I think this power supply, yeah, the power supply is on all the time. The on and off switch is just turning to 12 volts. So just be aware of that if you own one of these. The power supply is running and drawing some current. Likely to actually be, if I go back to my college days, something like 3% of what it would be. It's still something, and of course you're putting wear on the capacitors, aren't you, even if they're new. The trouble with using these industrial soldering irons is it's temperature controlled, but it's capable of getting quite hot. Right, so I can just put the lids on loosely. I'm going to have to whip the front off and do the meter lamp tomorrow. Take that out. Probably spray that volume control as well. Right, other lid. Or have we lost it already? It's going to be somewhere. I don't know whether it's gone down to Mr. Chippie's bench, but just for now we'll just finish off on here with the aerial. Disconnect it from the test equipment, plug it into the roof area, which is an Antron 99 or a Solarcon 99, 18-foot fiberglass or whatever length, something like that, mounted at gutter height on a single-storey building without the optional ground plane kit, fed with thin cable but industrial quality. Right, well, let's have a flick round. 19 Roger. 19 Roger, helps you put on full power. The usual culprits out there, not him. Right, there you have it. When we find the lid, the DNT B40 from 1981. Don't rush out buying these. They're not high performance sets, and the drive joints were a problem right from the word go. Thanks for watching.